What is going on, everybody, and welcome to part 16 of the Python Plays Grand Theft Auto and does a self-driving car series. So it has been a minute since we last spoke. I've been incredibly busy, but I have been working really hard on Charles getting this AI to improve as quickly as possible. So I'm going to try to cover all the changes that have been made so far up to this point. It's going to be really hard, but I think I can probably do it. Mute my sound before someone messages me on Skype and ruins it. So what I'm showing you right here is actually version 0.03 in training. I just wanted to show it because I won't be able to show it probably later on. It's like TensorBoard with this many data points is super likely to crash. But yeah, this is training over time. This is probably like 30-ish hours into training. So training is super slow. And I've had a lot of crashes. At least these first 4 crashes are from the Titan X Maxwell. This crash here was, actually I think this was this morning, before I started recording. I can't record while it's training, because it uses all of the GPU. But actually this crash here was because the power went out last night. But anyway, yeah, it's been crashing a lot. And unfortunately, the original Titan X Maxwell is, I believe, dead. It just, first it started off crashing every, maybe 12 hours. And then all of a sudden it just started crashing like every 15 seconds. And then finally it crashed so bad, it basically, I couldn't reinstall any graphics drivers to it. It said it had no drivers at all. Only would, go to one screen rather than all the screens that were connected. I tried to install a new graphics driver. I deleted all NVIDIA stuff, and that seemed to work temporarily, but then it still kept crashing. And when it worked temporarily, it was very odd because NVIDIA wasn't even installed on my computer. Like, it was nowhere to be found. And like, if I looked up the version of the graphics driver, it said none. So, yeah, I don't know. So right now I'm actually running the GTX 1080 Ti. And using that for training. I'll talk a little bit more about that towards the end of the video. But yeah, man down. So unfortunate. This is about a year old. Actually, the card's much older than a year, but I bought it on eBay. So there is no warranty to be had on this card. Boo. So now onto some changes. So I've outlined a lot of the changes on just cyber.io, psyber.io. No real code changes besides the models are posted here, but it's just some general information that you can kind of read through. So some information on 0.01. I'm just going to, since I already kind of covered 0.01, I will just show, this was the AlexNet model that I used. It's a modified AlexNet. It's like 28 layers. But yeah, it's basically AlexNet just expanded a little bit. Like, this is expanded here and here and then here. But yeah, that's the model. That wasn't shown at the time, so I just wanted to briefly show that. And just to remind everybody, since it's been so long, this was a 160 by 120 pure convolutional neural network. Saw everything on a frame-by-frame basis, made decisions on a frame-by-frame basis, irrespective of previous frames and decisions. Moving forward, obviously we want memory in the form of recurrent layers or anything to give it some sort of memory. Unfortunately, I have tried recurrent layers. I've tried motion blurs, optical flow, and even multiple frames on a convnet. I didn't think that was actually going to work, but it didn't work. Surprise. Anyway, I've tried a lot of stuff. It doesn't really seem to improve the network, so it's still a research question. More data, reinforcement learning, which I'll talk about in 0.03. And then granular control, which actually I have developed. I've even implemented it. It just didn't work super well, but I think there's a lot of hope for that, and I'll talk about that in a little bit and show some code for that. Then came 0.02, major change for 0.02, actually 2 major changes. One is that we include now color, so RGB, and then the other change is the model change. So actually for 0.02, I trained both that expanded AlexNet and Google's Inception v3. Now, unfortunately, Google's Inception v3, the idea of that is that you get, it's already pre-trained on ImageNet. And then you take that and just train like the last 2 or last 1 layer. I think it's the last 2 layers. You train those and that's it. So it's like a pre-trained model, and you just kind of train those on your own data, and it's like a really quick way to do like kind of like transference learning, basically. And unfortunately, I couldn't find a checkpoint file for ImageNet. So, or well, it is ImageNet, but for Inception on ImageNet. So yeah, so if you know of one, let me know. Where is that file? I thought that's the whole point of Inception. But anyways, I just trained the whole thing. I'm not 100% certain on exactly like the mathematics behind what merge does. So if someone has like a picture of what merge is doing, let me know, because I know what merge does with like arrays, and I just wonder, I would assume that's exactly what's happening here, but I'm not really sure why you would do that to a network other than, I really don't know. I just don't know. So anyway, I'm a little fuzzy on that. I just did Inception just to see what would happen, but what ended up happening, which was really interesting, was basically all the training data was made on my main PC. And then Charles runs over here on this PC. So what ended up happening was I trained both of these models, and then I tested them on this PC here, the main PC, which is where I created the data. And both models performed equally. Like, it was so close. So then I was like, well, I'll put each one on the Charles PC, let them run for a few hours, and then make a decision, and then ask people what they thought too. So I moved them over to the Charles PC, and right away the expanded AlexNet model just flops. It won't move. It doesn't do anything. And I'm just like, I don't know what the problem is. So that was really weird. And then the Inception model did work. Not as well, but well. So that's what I stuck with. I just stuck with Inception for that because it was the only one that worked. So it was really weird that they acted so differently. Same resolution, same graphic settings. I did figure out, well, the headlights were different. One headlights were the xenon headlights, one were the regular, but even after switching those out, no difference. So that I could tell. So it would appear that Inception is more robust than AlexNet, or maybe AlexNet is just simply like way too finicky or something to changing the data. Don't know. I really don't know why that happened. So that's definitely an area for some research there. Especially because the first AlexNet version didn't have that problem. So, weird. Anyway, moving along. That's kind of the big change, was just going with the Inception model. I'm going to keep trying to look into that one because I'm still really interested to know what caused that difference. But anyways, if you kind of want to read through a real summarized version of what's going on, and then same thing for future versions, I'll post 0.03 here when it comes through. You can go to psyber or cyber.io for that information. Also, I've updated the GitHub. So the GitHub, you'll land on this page, but you can go to versions and see the code for all the versions. Version 0.03 is already up. It's not trained yet, but it's up if you want to look at the code. The big things that you guys haven't seen in tutorial form has been changes to collect data, sort of train model, I suppose, and then sort of test model. So I'll kind of talk about those real briefly. So the big changes are these extra keys. So in the past, we assumed we were always just going forward, and then really we just had A and D for steering. Whereas now, we allow for a lot of the combinations, like forward right, brake left, brake right, and so on. So those are the major changes there. The code is super dirty. If someone wants to clean it up, have at it. Really, I'm still very deep in just kind of the development stage of all this, so I'm really not too worried about it. But if you want to fix it or poke fun at it, have at it. Train model, this is actually like training it on the actual data. Really, nothing's changed there. The only big thing that you got to watch out for is, of course, the output layer. Where is output? Let's see, model.fit. Oh, it should be where we define the model. Yeah, here. So AlexNet 2 output is 9. So as opposed to 3 before, now it's 9 output for the output layer. So 9 nodes. Then test model, same thing, just the other keys, other controls that you could possibly have. That's really it. Okay, so that was that for 0.01. 0.02 also has some motion detection in it. I actually found this online. The link for the full script is here, but I really chopped it down quite a bit just to be to my needs. But basically, it just measures pixel changes I kind of liked the exact way that they did it, and I felt like since I figured it out from them, I'll source them anyways. So there's the motion.py that I found from someone else. That just determines whether or not we're stuck. So it's kind of like a failsafe. The other failsafes I have are from a user named Fries, Frighz. They created two major mods so far. One is the anti-stuck mod, which basically, if we don't move a certain amount of distance in a certain amount of time, it determines we're stuck and it teleports us to a new location. So maybe we're at the bottom of the ocean, we're stuck in someone's backyard, or we're just going full throttle into a wall and we're not figuring it out. So it will fix those situations for us. So super useful. Also, the newest mod is for automatically setting waypoints, which I will talk about very shortly. So there's that. Also, just, a huge suggestion all the time is like, can't we control speed somehow? Well, we can. But it's challenged to come up with the algorithm that will do that. I don't want to arbitrarily limit speed. I want the network to pick the speed. So coming into VJoy testing, basically what's going on here is VJoy is a way to emulate a generic controller, but Grand Theft Auto 5 requires an Xbox 360 controller. No problem. We can use X360CE, which will let you take your generic controller and emulate an Xbox 360 controller. So what we can do is we can tie in VJoy to X360CE, and boom, we can use Python to emulate an Xbox 360 controller. I've done it. I've developed it. I've got the scripts ready. I've used it in game. I just can't come up with a good algorithm to actually try it, but you can kind of see my sample algorithm in the main.py basically, which will basically just takes the outputs and tries to figure out, how far left, how far right should we go. Also, if you can look at the main.py file, but also make sure you look at vjoy.py, because I've wrote out some decent-ish information here for you. Basically here, I've changed this file. Did I source this file? I did source this file. I'll have to see if they have a license, though. I'll have to put this license at the top. I should do that while I'm thinking about it. Let's see, Flandin. I don't see any, but I'll have to look more into it. If someone finds out, comment below if this should have a license on it. I think it probably has some license, surely. Anyway, I'll come back to that. Anyway, this is the original vjoy.py, but this is like the generic kind of outputs that you can have. And what I did was I marked down like throttle is not throttle. I think that must be for like a throttle pedal maybe or something. But really throttle is, I'm trying to remember, I think it's the right trigger. So W-axis, Z rotation. That's your actual throttle. Then you've got your left trigger. This is your thumb Y, like left thumb Y, left thumb X, X, Y. So this would be like for your steering. This would be for looking around. These don't appear to have any controls. And then buttons here are for like the A, B, X, and Y. Okay, so that's that. I've kind of commented out for that. I'll keep playing with it, but I think probably at least for like throttle control, we could take, the W output and the S output. Is it S? Yeah, S for brake. Take those two kind of, because they come out as a percentage basically from the neural network. Take those percentages, subtract brake from throttle, boom, you got it. You got a percentage, either of throttle if it's above 0, or if it's below 0, that's a percentage to brake. So there's stuff like that you can continue to try, and I'll keep messing with it, but for now, I just haven't really had too much time to play with it. But especially when I knew I was going to change the model anyway, and there's really not much point. Because, like for example, 0.01 was totally raw. 0.02, let's go, test model, is not total raw output. So what's happening here is it's applying an array to the output layer. So basically in your training data, you have to balance the training data. So in your training data, like 90+% of your data is some form of go forward. But if you train a neural network on that, the neural network will realize, oh, okay, so we just always go forward. And it'll just very quickly locally optimize to that, and that's not very good. So what you want to do is balance the data. But then when you balance the data, the neural network itself still won't predict out the real balance, right? So you have to then apply another, at least from my findings so far, you've got to apply an algorithm to the output layer. It's a super simple algorithm, but an algorithm nonetheless, and this is it. So maybe if we tweaked this a little bit and then went back to the controller, that could improve somehow. It's just going to take a lot of trial and error. Also, huge request or huge suggestion has just been memory stuff. I've tried it. I've done recurrent layers. I've done the convnets. I'm pretty sure I brought that up when we were going through. Just a huge research thing. You just got to keep trying it, and it just takes a lot of time, especially with like recurrent layers. Well, that's a new model. We got to train the model. Each model takes 24 plus hours just to kind of validate to see if it's even going to work. So it just takes a lot of time. So that's leading me into what I believe will be the end. Let me make sure I've covered everything that I really wanted to cover. Yeah, so this series is extremely expensive. So personally, I paid like $2,700 total for this machine here. I didn't have to, I wanted to. It's not like a Boohoo Centex kind of situation yet. But it's just an expensive one to run, and I don't necessarily want to I don't want to shut down the stream because having like a 24/7 live test has been super useful. I've gotten a lot of help and stuff from people. Also, the stream has been the source of basically the only reason I have a 1080 Ti right now to actually continue training this model since the Titan X Maxwell died. The only reason I have that is because through the stream donations. So the stream has been super useful too. People have seen things like, for example, no keys was still going forward. That was kind of remnant from an older model that it just no keys didn't make sense. But no keys works in these later models, so that was a mistake. All kinds of stuff people have really helped with. So I don't really want to get rid of the eyes. If I have to, I will take Charles offline and use him to train. I don't want to. It's not the way to go. The problem is, this series is making like nothing on YouTube. So normally I don't have a Patreon. I don't really need to ask for support because the ad revenue is always paid for it enough to where I just felt kind of silly asking for money. This series is different. This series is super expensive. It's costing a lot in electricity just to run these things 24/7. I'm losing hardware as we speak. It's a different kind of series, and unfortunately on YouTube it's making no money, which is unfortunate because it's the best performing series in every other way in terms of watch time percentage, in terms of views over this like a time period. Everything's great, yet the ad revenue is 1/20th of my typical ad rate, which is next to nothing. It's very bad. And I think it's just because it's self-driving cars in Grand Theft Auto. But Grand Theft Auto is the right environment. Like that's the right place for this. And I'm not really sure. There's no other game that I don't think would have a better ad rate. And then all like the kind of pre-made models that to do self-driving cars in aren't like Grand Theft Auto in the sense that it has so many variables. Like Grand Theft Auto is a huge challenge. So it's kind of a bummer. So anyways, through the stream, a lot of people have donated. You can donate to support the project through the stream. All the donations are totally public. All the things that I'm buying from the donations are totally public. All contributions go 100% towards like processing power. So electricity, hard drives, like hardware stuff, graphics cards, that kind of stuff. I'm not looking to supplement my income at all. 100% of contributions go towards making this thing go as far as we can take it. So you can donate to the stream. You can come to the stream and support Charles. Also, I set up a Patreon account. A lot of people have suggested I create a Patreon for the channel. I really don't have much reason to have it for the entire channel. If you want to support pythonprogramming.net in general, you can go to pythonprogramming.net to +=1, and you can subscribe there for $9 a month. That supports the entire channel. But if you want to support this specific series, I do have a Patreon up. If you want to support everything, you can go to +=1. But yeah, for this specific series, the Patreon, again, same thing as on the Twitch donations, all the contributions go towards processing power, basically. And then, yeah, I think that's it. So yeah, if you want to contribute, awesome. If you don't want to, that's fine. I'm going to take this series as far as I can. It's just when things are going to die on me that makes it hard. Also, just training the models. You know, a lot of the models that I've trained, you know, take 24 hours, and then you realize, it's not really working. Or like AlexNet, I spent 3 days training that model, and then it doesn't work in practice. It works on one computer, but not the other computer. So all kinds of stuff like this. It's just there's so much trial and error that more processing power would be easier. Now, some people suggest cloud computing. Well, let me explain cloud computing. Cloud computing is not to save money unless what you're doing is very short term. So if you're working on your like thesis and you just need to train a model real quick for like 4 or 5 days, sure, cloud computing is a great idea. Why buy all that hardware? But if you're running something 24/7 or training something 24/7, it's not a good idea. So to quickly price out for you, what happens when you buy cloud GPUs? What you're buying is a K80, which is old architecture. It's not ideal. The 1080 Ti I have is better than the half K80 that you'd buy in the cloud. So a K80 is actually 2 K40s pretty much just glued together. As I was saying, K40s are old. It's old architecture, it's old memory, it's not what you want, really. But regardless, one K40, so a half a K80, is $700 a month in the cloud. An entire K80, which arguably, now that my Titan X Maxwell is dead, I've got the 1080 and the Titan X Pascal running right now. That would cost $1,400 a month. And then if I still had my Maxwell, then hosting that for 24/7 would be $2,100 a month. So it just doesn't make any sense when a Titan or a 1080 Ti you can buy brand new for like $700 to $800. I opted for the overclocked from the factory GPU, just simply because after trying to overclock like 7 total GPUs in my lifetime, I've never had good success. I've always just had them die every time. Not die like the Maxwell, but die as in like they don't hold, like they don't. It's very hard to balance an overclock. So you can overclock like 1% to 2% or something crazy. Whereas like CPUs, you can overclock CPUs like somewhere between like 20 and 40+%. And they're just so much easier. So it's kind of silly, in my opinion, to buy a factory overclocked CPU. But for GPUs, it's definitely valuable. So I opted for that. But anyway, yeah, if you want to support, you can, like I said, you can do it either through donations on Twitch, which are logged, and then also for this specific series on Patreon, you can become a patron, or you can go through +=1. But +=1 is more general. I do use that for income. I use that to pay like house bills and car stuff and all that kind of stuff. But if you want to support this exact series, just in terms of like hardware and just seeing how far we can take it, Patreon or Twitch. So anyways, that's all for now. If you have questions, comments, whatever, feel free to leave them below. Once version 0.03 is done, I'll put that up. Once we get into reinforcement learning, we'll be back to the actual coding tutorials. I just didn't see much point in covering the coding of all of this stuff because it's basically version 0.01, just with like a couple lines changed here and there. So kind of silly. Other than that, the other thing that I think I forgot was Deep Dream. I'd really like to do Deep Dream at some point. Sorry if I'm repeating myself. I already talked about this. But basically, like, what is the network kind of seeing through Deep Dream would be really cool. So that'll be something else that I'm hoping to get out either by around version 0.03 or in 0.04 before, like, reinforcement learning or after reinforcement learning. Somewhere around there. But yeah, that's what you guys have to look forward to. Sorry it's been so long. Things have been crazy. I went to PyCon. While I was at PyCon, I was like sitting in the airport, and then suddenly like I like pulled up the stream, and like up to this point the stream had been getting like 20 viewers at a time or something at most. There was like 200 people in there. I'm like, what's going on? And it was like some article on rock paper shotgun. And then like through the day, like I think everyone just started seeing that, like journalists were seeing that on rock paper shotgun. And then like through that day, it was like I can't remember all of them, like PC Gamer, Polygon, Kodaku or something like that. I'd never heard of them. It was like tons of media on it. The stream went freaking nuts for a few days. It was brutal because I was out of town. And that was a pain. Anyway, that was pretty crazy. But I brought back a cold, and then for a brief moment, it looked like Linode was going to kick me off. My chair died. I'm actually on like this Can you even see this chair? Yeah, you can see. It's like a kitchen chair because my actual office chair just like broke. It like just swivels all over the place and just goes straight to the floor now. It doesn't like hold its position. So yeah, it's been a pretty hectic few weeks, but hopefully the updates will start coming more and more frequently. Hopefully graphics cards don't keep dying. So anyway, someone said you can put them in the oven. Which, I mean, it kind of makes sense because basically if you have like some of these solder points get weak or whatever, in theory you could maybe put it in the oven and that would work. But I mean, shoot, that's an interesting one. I don't think I'm going to do that right out of the gate, but yeah, I'm going to keep kind of trying to play with this one because I mean, it's a huge bummer. I'm going to really miss having the extra 12 gigs of VRAM. So, bummer. Anyway, that's all for now. Questions, comments, leave them below. Otherwise, I will see you in the next tutorial.